Good morning, everybody. My name is Mr. Kirsting, and today we're going to go over plate tectonics. We're going to rock your world. We're going to move mountains. Well, that might be a little melodramatic, but in geological terms, that's exactly what we're doing. Who knows about mountains? We've got a lot of mountains in Montana. How are they formed? Well, what is the tallest mountain you can think of? Mount Everest, right. That's very common. Okay, it's not Mount Everest. It's actually Mauna Kea in the USA. And up on the top of Mauna Kea, if we measure from the summit, above the ocean, below to the base of Mauna Kea, at the base of the ocean, it's the tallest mountain in the world. And it is formed by volcanic action. So we have volcanic magma coming up through the Earth's crust, making a cone that pierces the top surface of the water, creating the island. Now, if you want to talk about volcanoes, Krakatoa, 1883, it blew with 200 megatons of TNT, the equivalent of that. That's about 13,000 times Hiroshima bomb blowing up. That was the loudest sound ever heard on Earth. It was heard 13,000 miles away. It left 2/3 of the island gone. That's moving a mountain. But what makes these things happen? In the first place, we're going to look at the plates of the globe. In this case, here's the planet Earth, here's a globe. It is a sphere. And plates, they figure, it's a theory that there's plates here, there's a plate here, and they're in motion, they move. The continents on top of these plates seem to drift. They seem to drift apart, they seem to drift together. Now this theory is a theory only if it's not supported by fact, it's solely a theory, but the hypothesis supported by facts makes a theory a factual theory. And this tectonic plate is. Now how do we know that? All right, well let's look at our volcanic islands. Now, in this globe, we have the Earth's crust. Let me demonstrate this on the board. Here's the crust of the Earth. This is the surface of the Earth. The oceans, the continents on top of the surface of the Earth. Just below that, it starts getting hot. It is molten hot. On the surface, it is made out of rock. The continents, everything on the Earth's crust, litho, meaning stone, sphere, as in spherical, like the globe, shape of a ball. Below the lithosphere, or the Earth's crust, is an asthenosphere. Now this is a fancy way of saying the molten rock in between. It's spherical, asthenosphere. In the center of the Earth, they figure it is mostly iron, an iron ball. This is extremely hot. This is molten rock, and this is where it's cooled on the surface. Now, what's happening with this? Well, it's called convection. This is when the movement is propagated by the heat. Let me explain. If you've ever seen a pot of boiling water, on the bottom, it heats it up with the fire or the oven, the stove. It heats up the water. The water rises, and as it gets to the top, it cools because it's closer to the air. So it cools and it goes back down. So, just like here, from the heat of the center of the Earth, it goes up to the surface of the Earth. As it cools back down, it goes back to the center of the Earth. So it's hot, motions up, cools down, and then it revolves back down. This moves the plates of the Earth apart or together. How do we know this? What about a volcanic vent? Volcanic, it goes up, it creates a crack in the earth where a mountain is formed. an island, a volcanic island. Now we're using this little test tube, plastic test tube rack. Here's a vent in the earth. It's going through the crust. As the plate moves over it, it breaks up through the surface, breaks the surface of the ocean, creates a volcanic island. Now, the crust moves, the lithosphere moves to the side. The vent stays the same place. It creates another island. The crust, the lithosphere, moves again. The asthenosphere breaks some magma through, creates another island. It breaks to the right again, in this case, to the west, and it creates another island. A series of island chains are formed, and that's exactly what happened on the big island of Hawaii. There's a volcano, active. Maui, Molokai, Oahu, and Kauai over here. They are a sequence of islands, Kauai being the oldest, Hawaii being the youngest island. It's still not so eroded. Kauai, very eroded, very lush and tropical. Hawaii has got the active volcanoes. Now what happens? Well, this is proof that the plate is moving from the east to the west. Oh, wait, excuse me. That's from the west to the east. The plate is moving in one direction. So the oldest and the youngest islands show the tectonic plate movement. Now say, for example, this is two tectonic plates on the surface of the Earth. The Pacific plate is somewhat moving in this direction. The North American plate, they think it's moving a little bit northern. Now, how would they know this for sure? Well, they can send a laser beam to the moon, bounce off a mirror left on the moon from NASA, down to the Earth and measure the actual small, minute movements. Another proof of this theory. So, the North American plate is moving upward. The Pacific plate is moving this direction. So when the plates in a jagged formation, they will have a little bit of force before it really moves. It sort of doesn't, this cardboard, when it's cut like that, doesn't really move. If the plates were completely smooth, it would move. But since these jagged edges, like the crust of a pie, are a little jagged here, it takes a little bit of force before it gives away. That is the explanation for seismic activities, much like the San Andreas Fault in California, creating their earthquakes there. It takes a little pent-up energy before it gives the creation of earthquakes. The other thing I can explain with this is what happens when these plates move forward or move apart. It's called subduction. Super is above, sub below. So when a plate moves into another one, it creates a little bit of force where one folds over the other. The lower plate goes back into the asthenosphere and gets molten again. The other tectonic plate is building up a mountain range. Now that happens over here with India. India, the continent, is on this tectonic plate, including the Indian Ocean. India was once below and moved upward and pushed into the Asian plate. And that created the uplift, creating the Himalayan mountain range, including Mount Everest. So, as we've seen from last time about geothermal, cooling water, heating water from the heat of the magma, another example of a convection circuit. Heat rises, generates the power plant, and then they send cold water back to be heated geothermally, a source of energy. Well, what I'd like you to do is break up into about 3 groups or so and you'll have two pieces of paper, one blank, like this one, and the other one with here it is, map of the continents. So you take your map of the continents, and about 3 or 4, lightly circle with pencil these continents. Here's North American continent, South American, outline India, Australia, Antarctica, Africa, Asia. Circle the continents, cut them out, piece them together like a puzzle, tape them onto your other piece of paper. So they're all fit together like a piece of paper, a piece of one continent, because the theory is they drifted apart. 225 million years ago, they were once one continent called Pangaea. Each of you will come up and give a presentation and be responsible, delegate it out, where each person includes, as part of the presentation, some of these words up here, like convection, continental drift, tectonic plates, use lithosphere instead of Earth's crust, and explain how Pangaea drifted apart into the continents we see today. In groups, each of you give a presentation. And that's it. Good to go. Thank you.